Now we go to the beginning of the packet, okay? Now look, page 1 and 2. Page 1 and 2. If I was to give this packet to you all over again, page 1 and 2 would be page 2 and 3. And page 3 and 4 would be page 1 and 2, okay? We're gonna go through this packet. We're gonna start on page 3, okay, in just a minute. All right, but what I got here is like cut this problem 1 and 3 here. Problem 1 and 3 here. Distance off by 2 bearings with a beam. That's problem 1 and 3 on page 1. And this is problem 1 and 3 on page 3. Okay. And when I teach this stuff, I do this one first. This second. I wasn't exactly paying attention to the order of the handouts when I printed them out. All right, but there's a reason why I do it in this order. Okay, and it has to do with how the data is organized in table 7. All right, but we're going to be using table 7 for these. How am I going to know I'm using table 7? And when you read this, you're steaming on a course of 114. At 1122, you observe a lighthouse bearing 077. At 1133, the lighthouse bears 051. So I had a bearing in time, and I have a new bearing in time. How many times, how many bearings? Okay, great. Then what are they asking me? Oh, what's my distance off the time of the second bearing? Okay, so let's just read this. You are steaming on a course of 014. Your vessel is steering on a course of 074. At 17 knots, at 12 knots. At 1122, you observe a lighthouse. At 0214, you observe a lighthouse. It bears. At 1133, at 0223, you see it's the same information, just different numbers. The lighthouse bears 051. Oh, the lighthouse bears 135. What time is your distance off? Now here's the difference. What is this one asking? And what's this one? Second bearing. Second bearing. What's this one asking? A beam. What's this one asking? What's this one asking? You've got to read those last couple of words. The method is going to be basically the same to solve these two problems. But you have to read those last couple of words to know which column of the table you're going to go into. If it's second bearing, it's going to be the first column. Strange but true. Second is going to be the first. A beam is going to be the second. I'm going to draw a little picture now for you, and maybe that'll make sense for you, okay? A couple years ago, back in TNAV 1, you did something called doubling the angle on the bow, okay? So here's how that worked. You had some kind of course, okay? And you were here. This was time 1. And there was some bearing. It was X. Okay? It's a relative bearing. Off your port bow, it was X. Sometime later, time 2, you get a bearing on that same thing, and now it was like 10 degrees off your port bow, now it's 20 degrees off your port bow. If it was 15 degrees off your port bow, now it's 30 degrees off your port bow. You doubled that angle. Well, the interesting thing is that when you double the angle, you create an isosceles triangle where this leg distance run equals distance off. Distance run equals distance off. Okay? Cool. Am I a beam? No. If I'm gonna, so here's another triangle. This is distance beam. So I have distance off at time of what? Second bearing. First bearing. Second bearing. When I take my second bearing, I'm going to be a certain distance up. If I continue on my course, eventually I'll be distance off the beam. Which one happened first? Sydney. Did this happen first or did this happen first? Did this happen first? If I'm going like this, what's going to happen first? Is this going to happen first for me? Or is this? Yeah, the first one. The second one, this is beam. So the distance off at the second bearing happens before the distance off with a beam. You see that? Even though it has the word second in there, it happens first. This is my life. Boom. This is later in my life. Okay? Okay, now, because this creates an isosceles triangle, it's a beautiful thing. Distance run is distance off. So if that was 10 miles, that would be 10 miles. Okay? And if that's 10 miles and that's 10 miles, well, going through a whole process of like, this is one, I can figure out what that is too. Okay? Great. That's what we did in TNAV 1. This is what's called a special case, where we double. But it turns out that I can have any combination of numbers here. And now, in order to solve the relationship between the distance run, so what we're going to be doing here is we're going to be solving the relationship between the distance I ran and how far I'm off at that second bearing and how far I'm off at a beam. And in order to solve this trigonometrically, you'd have to use the law of sines and the law of cosines, not right triangles. Okay, because we start throwing other stuff in there, all right? And that's a little bit of pain in the butt. And it turns out that people took pity on lowly sailors back in the day. And they put together tables. So there is a table of all the ratios of these legs put together. That's called table 7. So instead of you having to do this, the trigonometry, I'm going to show you how you can look up the data in the table. That's what we're going to do now. Okay? So anyway, this is in the PowerPoint, but that's what I just did on the board. Okay, so you can go back and look at that little thing, and it might be slightly clear. Legs, la 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 la. Everything that I just said is right there. Okay. And by the way, interestingly enough, these are little running fixes. Okay. Now, it turns out that Bowditch on page 472 tells you how to use this table and gives you an example. And there's a little picture, and here's a little example. Okay. We're going to do one like this right now. Okay. We're going to use this table. I got to show you how to use this table. It's going to take a few minutes to show you how to use this table. Okay. And in the beginning of the books, that's page 472. The actual table is in like 5 or 6 pages. I gave you a handout of the tables. They're pretty small. You might want to bring your own Bowditch to the test. Otherwise, you're going to be like, you need a straight edge to reuse this table, by the way. In the beginning of the book, there's something called explanation of tables in the beginning of Bowditch. It tells you how all these tables were made and how to use them. And so this right here, this is on page, I don't know, it's like on page 20 or something like that. There's a little thing about table 7. Distance of an object by 2 bearings. To determine the distance of an object as a vessel on a steady course passes it, observe the difference between the course of the 2 bearings of the object and note the time of the interval between the bearings. Enter this table with the 2 differences, multiply the distance, blah, 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 blah. That's in Bowditch speak. Okay? That's how you're going to use this table. But I'm going to just try and translate it, and I'm going to give you a computer. This is the computer that I use to do these problems. Okay? It looks like a bunch of gibberish right now, but if you use this computer over and over again and you write it every time you do it, then you're going to have a method. Okay? You're going to have a method. All right? So, I gave you, I think on, okay, yeah, here you go. This is this handout, the very first page, okay? Right there, that's that method. Okay, it's going to take a little explaining to do. So I'm going to have to explain this little computer, and I'm also going to have to explain table 7, and we're going to do that. Okay? All right. Here you go. Okay, now, what problem is this? Distance off at time of second bearing. What page am I on the book in your handout? What page am I on in your handout packet? 3. I'm on page 3. I'm not on page 1, okay? I'm on page 3. Okay, I'm on page 3. All right? Okay. I am going to extract data from this problem, and I'm going to put it into a template. I'm going to put it into a computer. This is the first time you've probably ever seen this computer, so it's not going to make sense to you. But as time goes on, if you write these steps out over and over again, okay? So what I want to do here is you're steaming on a course of 114. What's my course? 114. What speed am I making? 17 knots. Okay, great. At 11:22, you observe a lighthouse bearing 077 true. Okay, so here's what's going on. Now, I don't draw the pictures anymore. Okay, but here's what's going on in this. You're steaming 114. So that's 114 there. I'm steaming this course. Okay, 1114. And I'm making 17 knots. At 11:22, you observe a lighthouse bearing 077. Okay, so that's 000, that's 090, so 077. Okay, so I'm gonna say that's my lighthouse. So this was, okay, so this is 11:22, okay, and I'm doing 114, and this is 077. That's a true bearing. At 11:33, the lighthouse bears 051. Okay, I don't recommend drawing these pictures. I'm just going to draw it for this first one, and I'm going to show you how we're going to use this table. Okay, so if it's at 051, so that's 090, that's 077, so that should be that's about 051. Okay, so here you go. So this is 077, this is 051. Okay, what time is that? That's 11:33. Okay, got it? Cool. Okay, now, what I need now is this is my course. I had a bearing of 077, I had a bearing of 051. What I need to calculate this angle, and I need to calculate that angle. I need the relative bearings. How am I going to do that? I'm going to take 114, and I'm going to subtract 77, and that's going to be the relative bearing for the first one. And then I'm going to take 114, and I'm going to subtract 51, and that's going to be the relative bearing of the second one. Course. True bearing. Okay? Course, true bearing. Now, I'm going to have a couple of columns here. Bearing 1. Bearing 2. And then over here is going to be time. Okay? What's my course? What did they give me? Okay? You observe a lighthouse. Okay, you're steaming 114. There's 114. At 11:22, you observe a lighthouse bearing 077. What time was that? At 11:33, you observe a light. You observe it bearing 051. What do you think I'm going to do with all these numbers? Sure. I'm going to calculate the difference now. So 114 minus 77 is going to give me 37. That's 37 degrees. 114 minus 51 is going to give me 63. That's 63 degrees. Okay? Cool. This is my relative bearing. Okay? This is my relative bearing. Great. I'm going to need those. What's going on here? What's going on over here? 11 minutes. Okay? So 11 minutes. What did I do in 11 minutes? That's my time. What I need to calculate is how far did I go? Okay? So I want my distance. I could call it my distance run. Okay? I want my distance. How am I going to do that?
Speed minus time.
Okay. So what I'm going to do here is I'm going to multiply this times my speed. My speed. And I'm going to divide it all by 60. Okay? You can do this every time. What was my speed? 17 divided by 60. What is 11 minutes times 17 knots divided by 60?
3.11.
Okay, yeah, I got 3.12.
Yeah.
Okay? All right. Cool. Now, this is that. This leg is 3.12. Okay? Now, here's the thing. I'll just give you a minute to catch up. 3.12. There's a relationship between this leg and this leg. This leg is going to be longer or shorter, and by some number, there's going to be a ratio, 1 to 1, 1 to 1.5, 1 to 0.8. And trig will tell you what that ratio is. Or you can let somebody else do the trig for you, and you can look up the ratio and then just multiply it. But it turns out that there are two things we can figure out. We can figure out what is our distance at the second bearing, or we can figure out what our distance is abeam. Okay? Second bearing is going to happen before a beam. Now we're going to go to a table. This is the table. We're going to go to table 7. So for you, you want to go, all right, so now we got to go to this table 7. Okay? Now, this table is a little wonky. It's going to take me a minute to explain it. Okay? The difference, so you got these, so I'm on the one here, what page is that? It's not numbered, but it should be like the very first or second page of the table. Yeah, you got to go to page 127. 126 is on the right-hand side, left-hand side, 127 is on the right hand, okay? Great. Now, what we're going to do is we're going to look up at the top. What is the top? What does that say right there? Difference between the course and the first bearing. Okay, Joe, what does that say right there? Okay, so Joe, which one of these is the difference between the course and the first bearing? What's that? 37. It's 37. Great. So I'm going to look for 37. Do I see 37? Shit. What do I have?
36.
And? So I'm gonna have to do a little something between them, right? Okay, but I can deal with that. I'm gonna show you how to deal with that in a second. Okay, so great. Sierra, what does that say? Well, where is that up on the board? Oh, that's this one. So the first one is the top, and the second one is the side. Okay? My little computer's doing some work for me. Cool. Now, you see all these freaking numbers in here? You see these numbers? These are ratios. They're telling you that this leg, if that was our number, they're saying that that leg is 3.22 times this leg. So if that was our number, it would be saying that this leg is, your distance off is 2.69 times this. Okay? So, Corey, slide down to take this 34 and slide down to 68. What's that number right there? 34, 68. What's the number? 1. So what does that say about your distance off? If this is 3.12 miles, Corey, how far off would I be at the time of the second bearing? 1 times, and so hey, 1 to 1. That's an isosceles triangle. What's 34 times 2? 68. Oh, that's doubling the angle on the bow. Anyway, so now here's the thing. Here's the thing. Okay, this is going to blow your mind. How many columns are there for 34? How many columns are there for 36? Okay, why do you think there's 2 columns for 34? The numbers aren't the same. Why do you think there's 2 columns? How many types of problems am I giving you here related to this table? There's distance off at second bearing, and there's distance off. There's distance off at second bearing, and there's distance off when abeam. I'm going to get a ratio for the rate for this leg to this leg. I'm going to get a ratio for this leg to this leg. Which one of these things comes first? Does my time to the second bearing come first, or does the time to the beam come first? This first column is the ratio for this leg. What's the second column for? It's the ratio for this leg. But wait, there's more. Wait, there's more. 37. Is there a 37 column? No. 63. Is there a 63 row? So what does that mean? I got to interpolate. Shit. I can only enter the table with even numbers. So what's my bracket? 36, 38. What's my bracket for 63? 62, 64. I got to go pull these numbers out. And I'm going to pull out little factors. So look at the question. Margot, what's the question asking me? Second bearing or a beam? Second bearing. Margot, am I going to look in the first column or the second bearing if I want second bearing? Which one happens first? Second bearing or a beam? Which one happens first? Second bearing or a beam? So which column am I going to look for if they're asking me about second bearing? Column 1 or column 2? Column 1. What is column 2 for, Nolan?
That was for the second bearing.
It's not for the second bearing.
No.
It's for the abeam. Because the abeam happens second. The second bearing happens first. The abeam happens second. Jacob, what's the first column for? Distance off at second bearing or distance off a beam?
Second bearing.
Second bearing. Bailey, what's the second column for? Distance off at second bearing or distance off a beam? A beam, okay? Dan, what's the first column for? Distance off at second bearing or distance off a beam?
Distance off, second bearing.
Nick H, What is the second column for? Distance off at second bearing or distance off a beam? Nick, what are we doing?
This way.
Yeah. Yeah, you're still on the hot seat.
Yeah.
What are we being asked to do?
Distance off second bearing.
So which column are we going to use, Nick? First freaking column. Okay, now. We want 37, but we don't have 37. So we're going to have to go down 36. So we're going to slide down 36 until we find 63. But we don't have 63. What we have is 62 and 64. So I need those two numbers. Okay? So I'm going to need four factors. Factor 1, factor 2, factor 3, factor 4. What's factor 1? 1.34. What's factor 2? 1.25. Okay? Right there. Nick Lewis. I just did 3662 and I did 3664. But I need two more factors. What am I going to do for those other two factors?
You're gonna do it between 38 and 62 and 38 and 64.
Okay, so in which column? First or second column?
Be the first column.
First column, because it's second bearing. Oh, shit. Okay, so I got to go to 38. And now what do I got to drop down to, Nick? You tell me, what is the next factor going to be? What's going to be the factor for 3862?
Be 38 and that's 1.51.
Yeah, and what's the factor after that?
1.40.
Yes. So this is 1.51. God, there's four freaking factors. How can I have, oh man, I wish I had an average. What should I do with that?
Add them all up.
I'm going to sum them. I'm going to sum them. So on your little computer thing, it says sum. Okay? So when you sum all those up, you should get 5.5. Okay? You should get 5.5. But, Joe, 5.5, I mean, I need the average of these. What am I going to do to get the average of four things that I added up?
9 and 4.
I'm going to divide by the number of factors, which in this case was 4. So now I'm going to divide by 4. And what do I get when I do that? You should get 1.375. What's that?
That's the ratio.
Nathan, what that's saying is that this leg is 1.375 times longer than this leg. Do I know how long this leg is, Nathan? I think we calculated it. The distance run is 3.12. This leg is 1.375 times longer than this leg. What am I going to do with the 3.12 and the 1.375, Nathan? I'm going to multiply this by the distance. And that equals 4.3. That's your distance off at the time of the second bearing. Oof. Okay? We're going to do, let's give you a minute to digest that, and we're going to do another one. But we're going to do, we don't have enough time, I don't know if we have enough time. Instead of doing another one of these second bearings, we're going to jump right to a beam. Okay? We're going to jump right to a beam. Olivia, we just did a time of second bearing. What column did we use in table 7? The first columns or the second columns? Okay, we use the first columns. Second bearing is always going to be the first column. Second bearing is always going to be the first column. Okay? Why is it always going to be the first column? Because it happens first. What happens second? A beam. The second column is for a beam. Okay? Oh shit. You're just going to have to keep track of this. So, Olivia, I'm going to do the same thing, but instead of asking you for the distance off, we'll change the numbers around in a second, but instead of asking you for the distance off at second bearing, I'm gonna ask you for the distance off a beam. What is gonna be the big difference between what I did here and what I'll do in the next problem? Where am I gonna get these factors from? The second column. The second column. Everything else is gonna be exactly the same. The difference is second bearing doesn't mean second column, it means first column. A beam means the second column. You just gotta get that, you just gotta own that.